Today we'll be going through a blog by Nikolai Gerald. He's one of the founding engineers at Amcode and he's really good with coding agents and everything regarding AI that is going on these days because they are one of the leading coding agents in this space. And he has written a really nice blog which is titled Kirby is Eating Context Engineering. And I just went through this blog yesterday and I thought of sharing this with all of you because I've been having similar thoughts about the current AI landscape and how things are moving and major model releases by big AI labs like Anthropic and OpenAI. So I think this is a good discussion to have, and this blog provides a good foundation for all of us. So the basic idea behind this is when when coding agents like Claude Code were released last year, it was fairly new. We were using it. It wasn't that good, but it was really better than Cursor and other coding agents. But to get the most out of these coding agents, we had to build certain workflows around that coding agent, around those large language models. So one of the earliest things that we started to do while using these coding agents was to have MD files, to have plan MD files, or to have to-do MD files. So we built that workflow around the coding agent, which helped us get most out of these coding agents. But what happened slowly was these models, these coding agents started to have these things built in. So one less step for us that we don't have to write any MD files. We don't have to write any to-do files. That is now inbuilt in coding agents. So this has been the case since past year. Like there is a major model release, there is a major coding agent release, and people start developing their workflows around it. And in the next release or one release after that, that is now incorporated in the model or the agent itself. So slowly, everything that we did around the model or the coding agent has been built in inside the model itself. So similar thing happened 3 to 4 months ago. Like people started talking about this term called context engineering, and Dexter Horothy was one of the first persons to talk about this. He gave a talk about this at the AI Engineer Summit. That was a really nice talk. He also developed 12 factor agents, which also talked about context engineering. So basically, it's about managing the context in a way that you can get most out of the model. There are multiple techniques to do that. But it has been just 3 to 4 months since that talk was released and context engineering started being a thing in the market. But now, slowly, these models are killing it because they now have context engineering built in. So, one less step for us and major advancement for these models. So, this article basically talks about the same thing. So, if you see, he has really nice section on a primer on context engineering. So when you look at superficial level, an LLM doesn't have many things to do, sorry, many things to worry about. Its way, it's a blob of tokens, next token prediction. Yeah, but the effective input is not just your prompt. Like prompting the model about what you want to do, that is not enough. You need to provide enough context so that it can do the thing for you. And while doing that, we provide many tools, MCPs, skills, and a lot of things, many MD files. So when you provide all of that, the context tends to get poisoned or corrupted. So managing all of that comes under context engineering. So if you see, there is a really nice graphic around this, seeing how the context gets accumulated as you keep on giving it instructions, as it keeps on doing multiple tool calls, MCPs, and everything. So this bloats the context, and as the context is bloated, the capacity of LLM to give you correct results keep on increasing. So then a very interesting thing also again by Dexter Horothy research plan implement RPI was Like he made that thing really famous. Like first you research about the code base and put findings in research.md. Then you plan on top of that. You throw away the research MD after that. Like basically you give the research MD and a prompt and create a plan, and the research no longer matters, or you can keep it in as a static file. Then you go on to the last step, that is implement, and at each step you keep on clearing the context, like manual compaction of the context. And this was considered one of the best ways to get most out of coding agents. But now these things are built in inside the language models. Sorry, in the models or the coding agents itself. Even this thing is being taken care of by sub agents. And like just like how these models, these coding agents ate all planning, to-do files, research files. Now it is going to eat like eating context engineering as well. So he has written it really nicely. All of them help the user context engineer, but they have a bunch of problems. They are very user driven. They can be trained on. They don't have any benefit beyond the current thread. Everything that you learned is lost. So yeah, I watched them pause and inspect the code base, sketch an internal plan, and only then start editing. They ran smaller validation loops before big changes, recovered from bad reads without me stepping in, and actually remembered stuff I told it earlier in the thread. So what he's trying to say is he didn't have any MD files, he didn't do any planning as such, he didn't do any research as such. The agent on its own went ahead, researched the code base, did some validations, and then only started applying. So he's talking about a new concept called from context engineering to code base engineering. So I can summarize it very simply for you. So you need to structure your code base in such a way that your agent has access to all of your main files, main repos, or all of your infrastructure inside same repo. That is, the best case is to have a mono repo, but it's not possible for all of you. But if you have a mono repo, now the agent is capable enough to go look at your backend, look at the API, and then come up with a plan to implement that thing on the front end, or look at your testing infrastructure, look at how deployments happen. So if everything is provided in a box or at a singular place, that is less effort for your agent, and it is trained like that. So it makes more sense to structure your code base according to the agent so that it becomes easier for it to work on your tasks. So yeah, make the code base agent proof, use naming conventions that the model has been trained on, so it is easier for it to find out about the files, about the functions, externalize knowledge. Every time you find yourself re-explaining a pattern, a convention, or a constraint to the agent, stop and ask, why isn't this in the repo? Add it to an agents.md as a short, precise rule. So give your agent as much context as possible inside the repo itself. Same, add missing capabilities. Sometimes the agent needs a capability that doesn't exist yet. A script that validates a migration, a wrapper around an internal API to get debug information, a way to run build that doesn't blow up the context window. So you can provide all of these things so that your chances of getting a really good production grade code increases. And here he's talking about making context last longer, move context around, build feedback loops. This is really important. So there was one company, I don't remember their name, but they implemented software factory where agents do all of the stuff. They don't look at the code, but if they are not looking at the code, there are no code reviews. How are they validating stuff? How are they testing? So for that, they built something called faithful mocks. So what is a faithful mock? Suppose your product is dependent on Slack APIs and Slack charges you per API call. How can you let these coding agents test on top of that APIs, because that will cost you a lot. So what they did was they built simple stubs or simple working APIs that replicate the behavior of Stripe or sorry, or Slack or any platform that they're using. And this is called faithful mocks, and this is a very clever way to like test actual user stories in your entire pipeline. So yeah, and he's suggesting Kirby will lead this too, that these coding agents, these models will also slowly encompass this thing in themselves. And he's talking about a major open gap in agents. That is, to these current agents don't have memory of the past conversations. Like they don't read through the past chats, like what did we work on before, what did we work on last week, or stuff like that. So I think it's not that hard for Claude Code or Codex team to add these things. If they add this, it would be a really helpful feature. So this is one of the open gaps that he's talking about. And one more open gap that he talked about was they right now can't read logs automatically. Suppose you have a API which failed and there were some logs generated. What if the agent can read those logs directly, come up with a solution, and create a plan or PR for you, and you don't have to do anything? So right now they can't read it on their own. You have to tell it manually. So this could be a nice workflow. Someone might build something around it, might build some software factory around it, and slowly Cubby will lead this to these models, these coding agents will have this built in few days. So we are in a really interesting era where things are moving so fast. Nobody knows where this is going, but we should try our best. We should keep up with what's going on. And I think Nikolai is a really great guy. And you should follow his blogs, his podcasts, and all of it because he provides really good insights upon what's going on in the market. Yeah, I just wanted to talk about this article. Like I didn't read it fully, but yeah, we talked about the major ideas about it. I would highly recommend you to go through the blog by yourself. I'll give a link in the description or the comment. Yeah, see you guys and bye bye.